Okay. Once again, good morning, all of you. So, in yesterday's lecture, we have discussed about the general equation in cylindrical coordinate system and spherical coordinate system. Yesterday, we have discussed about the general heat conduction equation in cylindrical and spherical coordinate system. So, we know that in cylindrical coordinate system, we have to locate any point. So, for that locating particular point in that particular coordinate system, there is a requirement of three variables. What are these variables? That first variable is r, then second variable is phi, and third variable is z. So from this diagram we have to understood what is meant by r. R is nothing but distance of that particular point from the z axis. Okay, then what is meant by z? Z is nothing but distance of that particular point from the horizontal plane, and then phi is nothing but we have to take the projection of that particular point in the horizontal plane, and we have to draw one line from the center to that particular point, and that line makes with the angle with the x axis, that is nothing but phi. So in the cylindrical coordinate system we have to locate any point. So for that locating that particular point, there is a need of these three variables, that is r, phi, and z. So from the derivation we get the final equation. That equation is nothing but general heat conduction equation in cylindrical coordinate system. And what is that equation? Dou square t upon dou r square plus 1 upon r dou t by dou r plus 1 upon r square dou square t upon dou phi square plus dou square t upon dou z square plus qg by k is equal to 1 upon alpha into dou t by dou t. So this is the final equation, and that equation is nothing but general heat conduction equation in cylindrical coordinate system. So for the suppose we have to consider internal heat generation is 0, qg is equal to 0, then steady state is there, and unidirectional flow is there. So at that time what will happen? Qg is equal to 0, then dou t by dou t is equal to 0, and temperature is not function of phi and z. So whatever the quantities or whatever the parameters with respect to r we have to consider. Okay, so from that we get the equation d square t upon dr square plus 1 upon r into dt by dr is equal to 0. And this is the equation for the condition when the unidirectional heat flow is there, internal heat generation is not there, and steady state is there. So from that we have written the equation. So 1 upon r is not equal to 0, so remaining term becomes 0. So d by dr into r into dt by dr is equal to 0, and from that we get the equation r into dt by dr is equal to constant. So this is the equation when there is a steady flow is there, unidirectional heat flow is there, and internal heat generation is 0. So for that we have to use this equation, r into dt by dr is equal to constant. Okay, so this is the equation for the cylindrical coordinate system. Similarly we have derived the equation for the spherical coordinate system. In spherical coordinate system, temperature is the function of r, phi, and theta. So r is nothing but distance from the center to that particular point, then phi is the same as the earlier condition, and theta is nothing but the angle, whatever the line we have drawn from the center to that particular point, that line makes with the angle with the z direction, that is nothing but theta. So by using this we have written the equation. From the derivation we get the equation as a general heat conduction equation in spherical coordinate system, and this is the final equation for the spherical coordinate system. And we have assuming the some condition, that is internal heat generation is 0, then steady state is there, and unidirectional heat flow is. So from that conditions we get as a equation 1 upon r square d by dr into bracket r square dt by dr is equal to 0. So this is the equation we have to use for the solving the derivation for the heat conduction through this sphere. Okay, तर ह्या इक्वेशनचा काय उपयोग आपल्याला? जनरल हीट कंडक्शन इक्वेशन इन सिलेंड्रिकल कोऑर्डिनेट सिस्टम and general heat conduction equation in spherical coordinate system. By using these equations we have to find out the heat conduction through the cylinder and heat conduction through the sphere. Okay, so after that we have discussed about the heat conduction through a hollow cylinder. So for that we have considered this is a one hollow cylinder. So inside surface having radius is r1, then outside surface having radius is r2. Then we have considered one small element having radius is r and thickness is dr. And whatever the inside surface having temperature is T1, and whatever the outside surface having temperature is T2. So in this case we have considered the heat flow is radially takes place, because in axial direction or in both ends we have using the insulation. So because of that what will happen? Heat is flowing in the radial outward direction. So our aim is to calculate the value of Q, means how much amount of heat is coming out from this particular cylinder in the radial outward direction. So we have to find out the value of Q. Okay, So this is the diagram we have drawn in yesterday's lecture. So T1 is nothing but inside surface temperature and T2 is nothing but outside surface temperature. So from this, okay, so for deriving this derivation, we are using the general heat conduction equation in cylindrical coordinate system. So we have written that equation. So we have assumed some condition, that is a steady state is there. So for steady state, anything with respect to time is equal to 0. Unidirectional means we have to consider only one direction, that is with respect to r. So whatever the phi and z, that parameters becomes 0. Then no internal heat generation, so Qg is equal to 0. So according to that, we get the one equation, that is r into dt by dr is equal to constant. Okay, r into dt by dr is equal to constant. So rewrite this equation, dt is equal to c into dr by r, that is the equation number 1. Okay, then integrate above equation. So by integrating this equation, we get the integration of dt is nothing but t, c integration of dr by r is nothing but ln of r plus constant, that is c1, and that is the equation number 2. So our aim is to calculate this value of temperature. So for the calculation of temperature, there is need to calculate the values of the constant, that is c and c1. So for the finding out the values of c and c1, there is a need of boundary condition. So from that diagram, so from this diagram, if radius is r1, ही ज्या वेळेला radius r1 असणार आहे त्यावेळेला इथलं टेम्परेचर काय आहे तर t1 आहे. So first boundary condition is, if r is equal to r1, then t is equal to t1. And similarly, if this r value becomes r2, then at that time, what is the temperature? Temperature is nothing but t2. So you have to use these two boundary condition. If r is equal to r1, then t is equal to t1, and if r is equal to r2, then t is equal to t2. So by using these two boundary conditions, r is equal to r1, then t is equal to t1, and r is equal to r2, then t is equal to t2. So put these boundary conditions into equation number 2. Then we get the two equation, that is t1 is equal to, by putting the first boundary condition, we get the equation as a t1 is equal to c1 ln r1 plus c1, and that is the equation number 3. Similarly, we have to put the second boundary condition. Then we have to get the equation number 4, that is t2 is equal to c into ln of r2 plus c1, ln of r2 plus c1. तर इथपर्यंत आपला काल पार्ट संपलेला आहे. Now next we have to write down. Okay, t1 is equal to c into ln of r1 plus c1 is, that is the equation number 3, and t2 is equal to c into ln of r2 plus c1, that is the equation number 4. Okay, now subtract the equation 4 from the equation 3. So equation 3 minus 4. So subtract the equation 3 or equation 4 from the equation 3. So therefore t1 minus t2, t1 minus t2 is equal to what? C into ln of r1 minus c into ln of r2, c into ln of r1, because plus c1 that will be cancelled, c1 minus c1 becomes 0. So what is the remaining term at the right hand side? So t1 minus t2 is equal to c into ln of r1, c into ln of r1 minus c into ln of r2, c into ln of r2. Okay, so we have to take c as a common. So t1 minus t2 is equal to c into ln of r1 minus ln of r2. Log minus log, what is the equation for the log minus log? That is ln of r1 by r2. So write down t1 minus t2 is equal to c into ln of r1 by r2. Log minus log, what is the equation? Log of division, that is ln of r1 by r2. So from this equation, we get the value of constant c. Our aim is to, first of all, we have to calculate the value of constant c and constant c1. So by using that boundary conditions, we have calculated the value of c. And what is the value of c? C is equal to t1 minus t2 divided by ln of r1 by r2. ln of r1 by r2. Okay. All of you write down this c. C is equal to t1 minus t2 divided by ln of r1 by r2. Okay. Or how to write this equation? So c is equal to minus, we have to take common negative sign as a common. So therefore t1 minus t2 divided by ln of r2 by r1. म्हणजे वरच्या इक्वेशन मध्ये ln of r1 by r2 आहे. In next equation that we have changed, that is ln of r2 by r1. So we have to take the negative sign. For the calculation purpose, we have taken the negative sign as a common. So c is equal to what? C is equal to minus t1 minus t2 divided by ln of r2 by r1. Okay, so this is the value of c. So put that value of c into any equation. Okay, So what is the equation of T1? So T1 is equal to C into ln of R1 plus C1. So in this equation we have to put the value of C. So therefore we get the value of C1. Okay. So write down this T1 is equal to C into ln of R1 plus C1. हे आपलं इक्वेशन नंबर कुठला सांगा? इक्वेशन नंबर 3 आहे. T into C into ln of R1 plus C1. So in this equation we have to put the value of C, then we get the value of C1. Okay. So write down this T is equal to C into ln of R1. T1 is equal to C into ln of R1 plus C1. Now we have calculated the value of C. So put that value of C, that is T1 is equal to what? T1 is equal to minus T1 minus T2 divided by ln of R2 by R1 into ln of R1 plus C1 plus C1. So put that value of C into this equation. Okay. So from this equation we get the value of C1. So what is the value of C1? So C1 is equal to what? So take this term as a another side, so that becomes positive. So C1 is equal to what? T1 plus T1 minus T2 divided by ln of R2 by R1 into ln of R1. So this is the value of constant, that is C1. Okay. So from these boundary conditions we get the value of C and value of C1. Okay. Value of C and value of C1. Okay. So now put these values into equation number 2. जे काय तुमचं equation number 2 आहे. So this is the equation number 2. T is equal to C into ln of R plus C1. So in this equation we have to put the value of C and C1. We have to put the value of C and C1. Okay. So put these values in equation number 2, that is T is equal to C into ln of R plus C1. So in this equation we have to put the value of C and C1. So what is the value of C? C is nothing but minus T1 minus T2, sorry, minus into T1 minus T2 divided by ln of R2 by R1 into ln of R plus what is the value of C1? C1 is nothing but T1 plus T1 minus T2 divided by ln of R2 by R1 into ln of R1. Okay. So put the values of C and C1 into equation number 2. And what is the equation number 2? That is T is equal to C into ln of R plus C1. त्या equation मध्ये त्या values put करा C and C1 ची. From that we get the value of T, that is temperature. Temperature at any point for the cylinder. Okay. Then we have to take this T1 in the left hand side. So T minus T1 is equal to what? So this positive term is there and this is negative term. So we have to take the positive term at the left hand side and negative term at the right hand side. So from that we have to write the equation T minus T1 is equal to what? T minus T1 is equal to T1 minus T2 divided by ln of R2 by R1 into ln of R1. म्हणजे ही जी राईट हँड साइडची टर्म आहे ती आपण इथं घेतलेली आहे पॉझिटिव्ह आहे म्हणून आणि then minus T1 minus T2 divided by ln of R2 by R1 into ln of R. Okay. So from these two, so from these two equation, right hand, there are two equations. In that we have to take the T1 minus T2 as a common. So we have to take the T1 minus T2 as a common and we have to take that term into the left hand side. So it is at the denominator. So T minus T1 divided by T1 minus T2. And what is the remaining term in the left hand side? That is at denominator is same. That is ln of R2 by R1, ln of R2 by R1. So we have to take that as common. So what is the remaining term? ln of R1 minus ln of R. So log minus log, what is the equation? ln of R1 by R. So all of you write down. Okay. So we have to put the values of C and C1. Then we get the equation for the temperature. And we have to written that equation in the form of T minus T1 divided by T1 minus T2 and is equal to what? ln of R1 by R divided by ln of R2 by R1. ln of R2 by R1. Okay. Up to this, all of you written. Unmute yourself and tell me or put that message in the chat box so that I will proceed. लिहून घ्या ज्यांचं राहिले त्याने. Up to this आपल्याला काय फाइंड आउट करायचं आहे? रेट ऑफ हीट ट्रान्सफर थ्रू दॅट पर्टिक्युलर सिलेंडर इन दी रॅडियल डायरेक्शन, म्हणजे रॅडियल डायरेक्शन मधून त्या सिलेंडर मधून किती हीट फ्लो होणार आहे. व्हॉट इज द इक्वेशन फॉर दॅट? सो वी हॅव टू फाइंड आउट द व्हॅल्यू ऑफ क्यू. So we know that what is the equation for the q? Q is equal to k into a into dt by dr. So by using that equation we have to find out the value of q, but we don't know the value of temperature. So for that we have calculated the value of temperature, then we have to take the derivation and we have to put that value into that equation and we get the value of q. Okay, or improve your writing speed fast. It is completed. Anyone unmute yourself and tell me or put that message in the chat box so that I will proceed. सगळ्यांनी लिहिले का बघा? Constant c, then value of c1, then put that value of c and c1 into this equation. So from that we get the value of t, then t minus t1, and what is the final equation? T minus t1 divided by t1 minus t2 is equal to ln of r1 by r divided by ln of r2 by r1. ln of r2 by r1. ln of r2 by r1. Okay, up to this all of you written? Anyone? Yes sir, have completed. What about others? व्यवस्थित लिहून घ्या सगळ्यांनी, because this subject is very very important. Without understanding heat transfer subject we didn't go for the mtech in heat power. Okay, so this is the base for the mtech in thermal or heat power, and in gate exam also 7 to 8 marks for the heat transfer subject is there. So all of you understand the meaning of each term. What is the equation for the cylinder? What is the general heat conduction equation? What boundary conditions we have to consider? So from that how to calculate the value of temperature. Okay, so we have to remember these all equations. Okay, so we get the final equation t minus t1 divided by t1 minus t2 is equal to ln of r1 by r divided by ln of r2 by r1. Okay, then how to write that same equation in this manner? इथं आपण काय केलेलं आहे बघा, t minus t1 divided by t1 minus t2 केलेलं आहे, आणि इथं आपण इंटरचेंज केलेलं आहे. सो बाय इंटरचेंजिंग दी साइन वी गेट द इक्वेशन एज ए t minus t1 divided by t minus t1 divided by t2 minus t1 is equal to t2 minus t1 is equal to ln of r by r1 ln of r by r1 divided by ln of r2 by r1 ln of r2 by r1. So this equation is simple as compared to that equation to remember. T minus t1 at the right hand side t1 is there t2 minus t1, and in the right hand side ln of r by r1, and similarly ln of r2 by r1 is there. Okay, so we have written the equation in this form. So from this equation temperature distribution is logarithmic, and temperature at any point in cylinder can be expressed as a function of radius only. म्हणजे जे काही सिलेंडरचं जे काही टेम्परेचर चेंज होत जाणार आहे रॅडियल डायरेक्शन मध्ये, ते कशाचं फंक्शन असणार आहे? इट इज द फंक्शन ऑफ ओनली रेडियस. इट इज द फंक्शन ऑफ ओनली रेडियस, अँड दिस इज द इक्वेशन ऑफ in the form of logarithm. So temperature distribution for the cylinder is logarithmic. आता आपण प्लेन वॉल पहिला बघितलेले, प्लेन वॉल मध्ये जर टेम्परेचर डिस्ट्रीब्युशन कसं आलतं आपलं लिनियर आलतं. सो देअरफॉर इन दी प्लेन वॉल देयर इज अ स्ट्रेट लाईन फॉर द टेम्परेचर डिस्ट्रीब्युशन. बट इन दी cylinder, from this equation we said that temperature distribution is logarithmic. Temperature distribution is logarithmic, and from this equation we can say that temperature at any point in cylinder can be expressed as a function of radius only. म्हणजे according to radius that temperature will be changed. That temperature will be changes. Okay, so all of you write down the statement. Therefore temperature distribution is logarithmic. Temperature distribution is logarithmic, and temperature at any point in cylinder, temperature at any point in cylinder can be expressed as a function of radius only, as a function of radius only. कारण इक्वेशन मध्ये जे काय टेम्परेचर चेंज होणार आहे ते विथ रिस्पेक्ट टू काय असणार आहे, रेडियस असणार आहे. बाकीची टर्म कुठलीच नाही इक्वेशन मध्ये. सो फ्रॉम दॅट वी सेड दॅट टेम्परेचर ॲट एनी पॉइंट इन सिलेंडर कॅन बी एक्सप्रेस्ड ॲज ए function of radius only. Okay, so our aim, what is our aim? We have to find out the rate of heat transfer through that cylinder. Means we have to calculate the value of Q. So what is the equation for the Q? We know that Fourier's law of heat conduction, that is Q is equal to minus K into A into dt by dx. Dt by dx is nothing but thickness. But in this case, what is the thickness? Thickness in the direction of radius. So instead of thickness, there is a thickness of that small element we have considered as a dr. Okay, so what is the, by Fourier's law, Q is equal to what? Q is equal to minus K into A into dt by dr. So write down by Fourier's law, Q is equal to minus K into A into dt by dr. Okay, then Q is equal to minus K into A into dt by dr. So what is the value of temperature? So in the last step, in this case here we have calculated the value of temperature. This is the value of temperature. So put that value of temperature into the equation. Temperature जे काय आपल्याला इक्वेशन मिळालेलं आहे, T is equal to this equation. So put that equation into this equation. Okay, so Q is equal to minus K into A into d up derivative with respect to r into bracket. What is the value of temperature? T1 plus, what is the value of temperature? T1 plus T1 minus T2 ln of R1 divided by ln of R2 by R1 minus T1 minus T2 ln of R divided by ln of R2 by R1. हे ऑलरेडी आपण टेम्परेचरचं इक्वेशन फाइंड आउट केलेलं आहे. सो पुट दॅट व्हॅल्यू ऑफ टेम्परेचर इनटू धिस इक्वेशन. Put that value of temperature into this equation. आता डेरिव्हेटिव्ह विथ रिस्पेक्ट टू काय कॅल्क्युलेट करायचं आपल्याला? वी हॅव टू कॅल्क्युलेट दी डेरिव्हेटिव्ह विथ रिस्पेक्ट टू रेडियस. So first term is T1, so there is a no radius, so derivative of constant is 0. Okay, then second term, the second term there is a no value of r. Second term मध्ये r नाही आहे, so derivative with respect to r is not there, so it is also constant. So derivative of this term also 0. Then in the third term, T1 minus T2 divided by ln of R2 by R1 into ln of R. So ln of R is there. So in this term R is there. So we have to take the derivative of this term. So we have to take common as a T1 minus T2 divided by ln of R2 by R1, and negative sign is there. And we have to take the derivative of ln of R. What is the derivative of ln of R? That is 1 by R. Okay. पहिल्या दोन टर्म मध्ये R नाही. So that terms are constant and derivative of constant is 0. And in the last term, ln of R is there. So we have to take the derivative with respect to R. And what is that derivative? 1 upon R. Okay. So from that we get the value of Q is equal to minus K into, what is the value of area? Area काय असणार आहे सांगा? सिलेंडरचा सरफेस एरिया. So from that area heat transfer will be takes place. That area is nothing but surface area of that particular cylinder. त्या सिलेंडरची लेंथ आपल्याला L दिलेली आहे. And we have to multiply by the 2 pi r, किंवा आपण त्याला पाय इंटू डी म्हणतोय, बरोबर, पेरी. सो पाय इंटू डी इंटू L, that is 2 pi RL is nothing but surface area of that particular cylinder. Cylinderचा surface area काय असतो तर 2 pi RL. So minus K into 2 pi RL into bracket minus T1 minus T2 divided by ln of R2 by R1 into 1 by R. Okay, so take the derivative, take the value of area and put the into the equation. So Q is equal to what? What is the final equation? So minus minus becomes plus. So Q is equal to 2 pi KL, because in area term 2 pi RL is there, and in this equation 1 upon R is there. So this R will be cancelled. So what is the remaining term? 2 pi KL into T1 minus T2 divided by ln of R2 by R1. ln of R2 by R1. So this is the final equation to find out the heat rate of heat transfer through the cylinder. म्हणजे सिलेंडर मधून जी काही हीट ट्रान्सफर होणार आहे त्याच्यासाठी आपल्याला कुठलं इक्वेशन यूज करायचं आहे फॉर द कॅल्क्युलेटिंग दी heat transfer through the cylinder. So what is that equation? Q is equal to 2 pi KL into bracket T1 minus T2 divided by ln of R2 by R1. ln of R2 by R1. ln of R2 by R1. हे जे इक्वेशन असणार आहे तर ह्या इक्वेशनचा यूज करून आपल्याला काय फाइंड आउट करायचं आहे? हाऊ टू फाइंड आउट दी व्हॅल्यू ऑफ रेट ऑफ हीट ट्रान्सफर. Q is equal to 2 pi KL T1 minus T2 divided by ln of R2 by R1. ओके, के म्हणजे काय असणार आहे? थर्मल कंडक्टिव्हिटी असणार आहे. एल म्हणजे काय असणार आहे? लेंथ ऑफ दॅट पर्टिक्युलर सिलेंडर. T1 is nothing but temperature of inside some surface. Then T2 is nothing but temperature of the outside surface. Then R2 is nothing but radius of outer surface, and R1 is nothing but radius of inner surface. So by using these terms, we have to calculate the rate of heat transfer through that particular cylinder. So from this equation, can anyone tell me what is the thermal resistance for the cylinder? Anyone? What is the value of thermal resistance for the cylinder? कोण सांगते? Unmute yourself and tell me the answer for the thermal resistance for the cylinder. त्या इक्वेशन वरून मला सांगा what is the value of thermal resistance for the cylinder? Anyone? Unmute yourself and tell me what is the value for the thermal resistance for the cylinder?
ln of R2 by R1 divided by 2 pi RL. 2 pi KL.
ओके, करेक्ट आहे. म्हणजे जे काही टेम्परेचर चेंज सोडून बाकीचं जे इक्वेशन आपल्याला कुठे घ्यायला लागेल? डिनॉमिनेटरला घ्यायला लागेल. ओके, सो T1 minus T2 that term will be at the numerator, and we have to take the 2 pi KL that term in the at the denominator, means that term will be going at the denominator of the denominator. So that term becomes the thermal resistance. म्हणजे टेम्परेचर चेंज कुठे असणार? न्यूमरेटरला असणार आहे, आणि ते सोडून जे काही बाकीचे टर्म डिनॉमिनेटर असणार आहे that term is nothing but resistance to that particular heat flow. म्हणजे heat flow ला ती टर्म काय करणार आहे? रेजिस्ट करणार आहे. and what is that term? ln of R2 by R1 divided by 2 pi KL. this equation मी कसं लिहिलेलं बघा. how to write that equation? you have to take only temperature difference at the numerator, because heat is transferring because of the temperature difference, and which factor opposes the heat flow? that factor is which is at the denominator. म्हणजे ही 2 pi KL आपल्याला कुठे गेला पाहिजे? डिनॉमिनेटरला गेला पाहिजे, कारण हीट ट्रान्सफर जी होणार आहे ती कशामुळे होणार आहे? बिकॉज ऑफ द टेम्परेचर डिफरन्स. सो वी हॅव टू टेक ओनली टेम्परेचर डिफरन्स ऍट दी न्यूमरेटर. हा 2 pi KL न्यूमरेटरला आहे. हा जर खाली घेतली टर्म ती कुठे जाणार आहे? तर डिनॉमिनेटरच्या डिनॉमिनेटरला जाणार आहे. सो ln ऑफ R2 by R1 डिवायडेड बाय 2 pi KL. म्हणजे ह्या दोन्ही इक्वेशनचं मिनिंग एकच आहे, पण इक्वेशन आपण लिहिताना वेगळ्या फॉर्म मध्ये लिहिलेलं आहे, लक्षात ठेवा. सो व्हॉट इज द स्टँडर्ड इक्वेशन फॉर दी heat transfer? So Q is equal to delta T upon thermal resistance. टेम्परेचर डिफरन्स डिवायडेड बाय थर्मल रेजिस्टन्स असते. जर ही दोन्ही इक्वेशन कम्पेअर केली तर आपल्याला कळतंय की व्हॉट इज द व्हॅल्यू ऑफ थर्मल रेजिस्टन्स? थर्मल रेजिस्टन्स इज नथिंग बट ln ऑफ R2 by R1 divided by 2 pi KL. Okay, so what is the value of thermal resistance for the cylinder? ln of this term is nothing but thermal resistance. Okay, so thermal resistance for the cylinder is equal to ln of R2 by R1 divided by 2 pi KL. ln of R2 by R1 divided by 2 pi KL, and this is nothing but by using this equation we have to calculate the resistance. म्हणजे ही टर्म काय करणार आहे? जे काय आन्सर मिळणार आहे आपल्याला ते आन्सर काय करते तर तुमच्या हीट फ्लोला अपोज करते. हे आपल्याला कशावरून मिळालेलं? इलेक्ट्रिकल सिस्टीम मध्ये. जसं आपला करंट फ्लो कशामुळे होते? बिकॉज ऑफ द पोटेन्शियल डिफरन्स, and at the denominator there is a resistance, and that resistance opposes the heat current flowing. So in that way, in the heat transfer, heat is flowing because of the temperature difference, and whatever the term which is at the denominator, that term opposes the heat flow, and that term is nothing but resistance to the heat flow. Okay, so from this equation we get the equation for the thermal resistance for this cylinder, and that is equal to ln of R2 by R1 divided by 2 pi KL. ln of R2 by R1 divided by 2 pi KL. ओके, नाही तर आपण फायनल तेच इक्वेशन लिहिलेलं आहे. हे जे इक्वेशन आपलं हीट कंडक्शन थ्रू दी सिलेंडर जे आपल्याला फायनल इक्वेशन मिळतं ते परत लिहिलेलं आहे मी एकदा. हेन्स Q इज इक्वल टू 2 pi KL into bracket T1 minus T2 divided by ln of R2 by R1. So by using this equation we have to calculate the rate of heat transfer through the cylinder. सिलेंडर मधून किती हीट ट्रान्सफर होत आहे ते कसं फाइंड आउट करायचं बाय युजिंग दिस इक्वेशन. Q is equal to 2 pi KL into bracket T1 minus T2 divided by ln of R2 by R1. ओके, सो दिस इज द इक्वेशन. हे जे इक्वेशन आहे ते कशाचं इक्वेशन आहे सांगा. हालो सिलेंडर साठी आपण इक्वेशन डिराइव्ह केलेलं आहे. हे कशावरून इक्वेशन आपल्याला मिळालेलं आहे. जनरल हीट कंडक्शन इक्वेशन इन सिलेंड्रिकल कोऑर्डिनेट सिस्टीम. ओके, नेक्स्ट वी हॅव टू डिराइव्ह द इक्वेशन फॉर द कंपोजिट सिलेंडर. आता इथं एकच लेयर होता, त्या सिलेंडर साठी आपण काय केलेलं आहे, हीट ट्रान्सफर फाइंड आउट केलेलं आहे. नाउ वी हॅव टू फाइंड आउट द रेट ऑफ हीट ट्रान्सफर थ्रू द कंपोजिट सिलेंडर. मीन्स इफ देर आर n number of layers are there. आता आपला एकच लेयर होता सिलेंडरचा. इनर रेडियस इज R1 and outer radius is R2. If suppose two layers are there, then what is that equation? So we have to derive that equation for the cylinder. Okay, so all of you write down the next point. Heat conduction through a composite cylinder. Next derivation, that is heat conduction through a composite cylinder. Heat conduction through a composite cylinder. ओके, हे लक्षात ठेवा. आपण पहिला प्लेन वॉल घेतलं, त्याच्यानंतर प्लेन वॉलचं कंपोजिटचं इक्वेशन फाइंड केलं. आता आपण सिलेंडर घेणार, त्याच्यानंतर सिलेंडरचं कंपोजिटचं आपण इक्वेशन फाइंड आउट करणार. त्याच्यानंतर आपण नेक्स्ट स्पियर घेणार आहे आणि स्पियरचं हीट कंडक्शन इक्वेशन फाइंड आउट केल्यानंतर आपण कंपोजिट स्पियर साठी पण इक्वेशन फाइंड आउट करणार आहे. तर तुम्ही ही समरी लक्षात ठेवा, म्हणजे आपण काय काय कसे कसे डेरिव्हेशन घेत जात आहे. Okay, so heat conduction through the composite cylinder. So write down first statement. Consider flow of heat through a composite cylinder. Consider flow of heat. Consider flow of heat through a composite cylinder. Consider flow of heat through a composite cylinder. Okay, so write down, draw this diagram. This is the diagram for the composite cylinder. In this case we have considered the two layers of the cylinder. Layer A is there, layer B is there. Okay, and at the inside of this layer there is a hot fluid, and outside of this B layer there is a cold fluid or air is there. Okay, so temperature of this outside air is nothing but temperature of cold fluid, and heat transfer coefficient is nothing but HCF. Okay, and at the inside of the cylinder there is a hot fluid. Okay, temperature of hot fluid is THF. Temperature of hot fluid, HF is nothing but hot fluid, and heat transfer coefficient of hot fluid is HHF. Okay, so this Q amount of heat is conducted out from that particular composite cylinder. म्हणजे जी काय सेंटरला हॉट फ्लुइड आहे आणि सराउंडिंगला जी काय एअर आहे, ते हॉट फ्लुइडचं टेम्परेचर कुठं जाणार आहे, सराउंडिंग एअरला जाणार आहे. तर ती डायरेक्शन दाखवलेली आहे क्यूची. ओके, heat coming out from that particular composite cylinder. Okay, then we have given the notation point 1, point 2 and point 3. Whatever the layer A, inside surface is layer 1, outside surface is layer 2, and for the B, outside surface is 3. So from that, for surface 1 radius is R1, for surface 2 radius is R2, and for surface 3 radius is R3. Okay, we have to consider only two layers. So for layer A, what is the inside surface and what is the outside surface? Radius R1 and R2. And for the surface B, what is the inside radius? That is R2, and what is the outside radius? That is R3. Okay, so all of you draw this diagram. सेंटरला काय असणार आहे बघा, सेंटरला जे आता लक्षात ठेवा, डॉटेड लाईन आपण का काढतोय, तर तिथला कुठला मोड ऑफ हीट ट्रान्सफर असते, कन्व्हेक्शन. Dotted line, what is the meaning of dotted line? There is a mode of convection because there is a hot fluid. So in the hot fluid, how What way the heat transfer takes place? Because of the convection. Okay, so at the center we have written that hot fluid. Then what is the temperature of the hot fluid? That is THF. And what is the heat transfer coefficient? That is HHF. Okay, similarly at the outside there is a air or there is a cold fluid we have to consider. And what is the temperature of that cold air? That is temperature of, that is TCF. And what is the heat transfer coefficient? एअर आहे म्हटल्यानंतर काय होणार आहे, तिथं कुठला मोड ऑफ हीट ट्रान्सफर असणार आहे? कन्व्हेक्शन असणार आहे. सो बिकॉज ऑफ दॅट वी हॅव ड्रॉन दी डॉटेड लाईन ॲट दी आउटसाइड ऑफ दी सिलेंडर. आउटसाइडला आपण डॉटेड लाईन का ड्रॉ केलेली आहे? तर तिथे एअर असणार आहे किंवा कोल्ड फ्लुइड असणार आहे. त्याच्यामध्ये कुठला मोड ऑफ हीट ट्रान्सफर असणार आहे? दॅट इज कन्व्हेक्शन. सो कन्व्हेक्शन इज डिनोटेड बाय दी डॉटेड लाईन and conduction is denoted by the dark line. Okay, so what is the heat transfer coefficient that cold fluid? That is HCF. Okay, so I have explained the meaning of each term. So I have to draw this diagram. If diagram is over, then put that message in the chat box so that I will proceed. समझले का meaning of this diagram? At center there is a hot fluid and at the surrounding there is a cold fluid. So from the hot fluid to cold fluid heat transfer is takes place. तर ती किती heat transfer होते ते आपल्याला काय करायचं? फाइंड आउट करायचं. We have to find out the equation for the Q. Diagram is over. Shall I proceed? If diagram is over, that put that message in the chat box. Over. Okay, so this is the diagram for the composite cylinder. For the composite cylinder, and our aim is to calculate the value of Q. म्हणजे ह्या composite cylinder मधून hot fluid करून जे काही सराउंडिंगला फ्लुइड आहे किंवा जे काही एअर आहे याच्यामध्ये किती हीट ट्रान्सफर होत आहे, वी हॅव टू फाइंड आउट फॉर दी composite cylinder. फक्त एक जर लेअर असतं तर ते आपण मागाशी इक्वेशन काढलेलं आहे. Q is equal to 2 pi KL into T1 minus T2 divided by ln of R2 by R1. So by using that equation we have to calculate the heat transfer for the hollow cylinder, and this is now we have to derive the equation for the composite cylinder. Means in this case we have to considering the two layers of the cylinder, layer A and layer B. Okay, in earlier equation there is only one layer is there. Now we have to considering the two layers. Means if there are, we have to connecting the two or more layers bonded together, then that is nothing but composite. That is nothing but composite. So we have to find out the value of Q. So first of all, write down the meaning of each term. THF. So what is the meaning of THF? The temperature of the hot fluid flowing inside the cylinder. So write down. First class again. THF. What is the meaning of THF? The temperature of the hot fluid flowing inside the cylinder. Temperature of the hot fluid flowing inside the cylinder. म्हणजे जे काय आपला इनसाइड सेक्शन असणार आहे त्याच्यामध्ये काय असणार आहे? हॉट फ्लुइड फ्लो होणार आहे. Temperature of the hot fluid flowing inside the cylinder. Then TCF is equal to the temperature of the cold fluid किंवा त्यालाच आपण काय म्हणणार आहे? एअर म्हणणार आहे. Temperature of the cold fluid in bracket air. TCF is nothing but temperature of the cold fluid in bracket air. Temperature of the cold fluid in bracket air. Then KA. What is the meaning of this KA? That is thermal conductivity of the inside layer A. Layer A ची thermal conductivity काय असणार आहे? KA is nothing but thermal conductivity of the inside layer A. Inside layer A. Then KB is equal to what? Thermal conductivity of the outside layer B. Thermal conductivity of the outside layer B outside layer B, outside layer B, then T1 comma T2 comma T3, T1 comma T2 comma T3 is equal to temperature at the points 1, 2 and 3, temperature at the points 1, 2 and 3, temperature at the points 1, 2 and 3, 1, 2 and 3, then L is nothing but, capital L is nothing but length of composite cylinder. Capital L is nothing but length of composite cylinder. Length of composite cylinder. Okay, length of the composite cylinder. Then HCF, HCF and HHF and HCF, inside and outside heat transfer coefficient. HHF म्हणजे काय असणार आहे, heat transfer coefficient for the hot fluid, and HCF is nothing but heat transfer coefficient for the cold fluid. That is inside and outside heat transfer coefficient, inside and outside heat transfer coefficient, inside and outside heat transfer coefficient, heat transfer coefficient. Okay, so this is the meaning of the each term. This is the meaning of the each term. सगळ्यांना समजलं असेल, सिंपल आहे. जे काय आपण डायग्राम मध्ये ड्रॉ केलेलं आहे, जे काय आपण नोटेशन्स दिलेले आहे, त्या नोटेशनचं काय लिहिलेलं आहे, तर प्रत्येक नोटेशनचं मीनिंग लिहिलेलं आहे. ओके, सो नाउ माय क्वेश्चन इज दॅट, आता at the center there is a hot fluid. So whatever the heat flowing through this convection, म्हणजे hot fluid मध्ये जी काय heat transfer होत असते because of the what convection, then after that heat will be transferred through the layer A, and after that heat transfer will be layer B, and after that heat transferring towards the air, that is because of the convection. म्हणजे इथं आपल्याला there are 4 equations are there. At the center heat transfer is because of the convection, in the layer heat transfer is because of the conduction, in the layer B because of the conduction, and after that at the surrounding there is a heat transfer because of the convection. म्हणजे टोटल हीट आपली किती ट्रान्सफर होणार आहे, Q amount of heat is transferred from that hot fluid to the cold fluid. म्हणजे Q amount of heat ही कुठल्या कुठल्या लेयर मधून ट्रान्सफर होणार आहे, म्हणजे कन्व्हेक्शन मध्ये पण जी काही हीट ट्रान्सफर असणार आहे होणार आहे ती काय असणार आहे, Q असणार आहे. Then whatever the heat transferring from the layer A, that is Q, then whatever the heat is transferring from the layer B, that is Q, and whatever the heat transferring that cold fluid, that is also Q. म्हणजे आतमधून बाहेरच्या लेयरला जी काय heat transfer होणार आहे, that is nothing but Q. So from that we said that whatever the heat transferring through that each mode of heat transfer means convection, then layer A, then layer B, and then layer that is convection layer. So that amount will be same. So we have to write down the equation for the each mode of heat transfer. So at the center there is a convection is there. So we have to write down the equation for the Q for the convection for the inside surface. Then we have to write down the equation for the conduction for layer A. Then we have to write down the equation for the conduction for layer B. And then we have to write down the equation for the convection at the surrounding. So can anyone tell me what is the equation for the center? At the center there is a hot fluid. So what is the equation for that? Anyone? Rate of heat transfer. Anyone unmute yourself and tell me the equation for that. Convection साठी आपण कुठले इक्वेशन यूज करतोय? What is the equation for the convection? Anyone? Unmute yourself and tell me the answer. What is the equation for the rate of heat transfer due to the convection? We have discussed one law related to the convection, that is Newton's law of the cooling. So what is that equation? Q is equal to what? For the hot fluid, heat transferring because of the convection. Anyone? कोण सांगतंय? कन्व्हेक्शन साठी काय इक्वेशन आपलं स्टँडर्ड? सगळ्यांनी लिहून घेताय का नाही? ऑलरेडी न्यूटन्स लॉ ऑफ कूलिंग आपण घेतलेला आहे. सो इन दॅट न्यूटन्स लॉ ऑफ कूलिंग we get one equation. Q is equal to what? What is that equation? Anyone?
HA into TS minus TA.
Okay, HA into TS minus TS. H म्हणजे काय असणार आहे? Heat transfer coefficient. So what is the heat transfer coefficient for the hot fluid? That is HHF. Okay. Then area. तर एरिया काय असणार आहे सांगा. आता इनसाइड लेअर असणार आहे. इनसाइड लेअरची रेडियस तुम्हाला दिलेली आहे R1. सो व्हॉट इज द रेडियस फॉर द इनसाइड लेअर, दॅट इज, हा सिलेंडर आहे. सो व्हॉट इज द एरिया फॉर दिस सिलेंडर, दॅट इज 2 पाय R1 into L. दॅट इज द सरफेस एरिया फॉर द इनसाइड लेअर. तिथं हीट ट्रान्सफर होणार आहे. पहिल्या हॉट फ्लुइडची हीट ट्रान्सफर कुठे होणार आहे, लेअर 1 वरती होणार आहे. सो व्हॉट इज द एरिया ऑफ दॅट, 2 पाय R1 into L. Then what is the temperature difference? What is the temperature of hot fluid, that is THF minus फर्स्ट लेअरचं टेम्परेचर काय असणार आहे, T1 असणार आहे. सो THF minus T1. ओके, सो दिस इज द इक्वेशन फॉर द कन्व्हेक्शन ऍट द सेंटर. देन व्हॉट इज द इक्वेशन फॉर द लेअर ए, एनीवन. लेअर ए मध्ये काय असणार आहे, विच मोड ऑफ हीट ट्रान्सफर इज देअर, दॅट इज कंडक्शन मोड ऑफ हीट ट्रान्सफर इज देअर. सो व्हॉट इज द इक्वेशन फॉर द कंडक्शन. आता आपण इक्वेशन फाइंड आउट केलेले मागच्या डेरिवेशन मध्ये. सो बाय युझिंग दॅट कॅन एनीवन टेल मी व्हॉट इज द इक्वेशन फॉर द लेअर ए. समजते बघा, सिलेंडर साठी हीट ट्रान्सफर काय असते ते इक्वेशन आपल्याला मिळालेलं आहे. Q इज इक्वल टू 2 पाय KL इंटू ब्रॅकेट T1 minus T2 divided by ln of R2 by R1. So by using that equation, can anyone tell me what is the equation for the layer A? Heat transfer through that particular layer A, only layer A. Layer A मधून किती हीट ट्रान्सफर होणार आहे त्याचं इक्वेशन आपल्याला पाहिजे. Anyone tell me that? Rhythm. कोण सांगतंय, मदन. सिंपल आहे. मागचं जे इक्वेशन आहे ते आपल्याला आपलं पहिलं जे आताचं डेरिवेशन झालेलं आहे, Q इज इक्वल टू 2 पाय KL इंटू T1 minus T2 divided by ln of R2 by R1. So in that manner we have to write down the equation for the layer A. Can anyone tell me that answer? कोण सांगतंय, धनश्री. समजते का नाही. आता सिलेंडर मधून हीट ट्रान्सफर काय आहे, व्हॉट इज दॅट इक्वेशन, Q इज इक्वल टू 2 पाय KL इंटू ब्रॅकेट T1 minus T2 divided by ln of R2 by R1. In that manner we have to write down the equation for the layer A. So what change will be there, Q is equal to काय ना सांगा, 2 पाय KL आपण म्हणतोय, म्हणजे 2 पाय K च्या जागेला काय येणार आहे, थर्मल कंडक्टिव्हिटी ऑफ लेयर A, 2 पाय K इंटू L. ओके, देन व्हॉट इज द टेम्परेचर डिफरन्स फॉर द लेयर A, दॅट इज T1 minus T2 divided by what is the radius for the layer, section 1 and section 2, R1 and R2. So therefore ln of R2 by R1. Simple hai. Similarly we have to write down the equation for the layer B, that is 2 pi into KB into L, T2 minus T3 divided by ln of R3 by R2. And similarly we have to write down the equation for the convection which is takes place the outside of the cylinder. And what is that equation, Q is equal to HCF into 2 pi R3 into L into T3 minus TCF. So in this way we have to understood the concept. Okay, so what are that 4 equations? The rate of heat transfer is given by, write down this 4 equation. Q is equal to HHF into 2 pi R1 into L. म्हणजे सेंटरला जे काही फ्लुइड असणार आहे त्याच्यामुळे जो काही हीट ट्रान्सफर होणार आहे त्याचं इक्वेशन असणार आहे. देन लेयर A मधून हीट ट्रान्सफर किती होत्या, देन लेयर B मधून किती हीट ट्रान्सफर होत्या, देन सराउंडिंग मध्ये जे काही एअर असणार आहे त्याच्यामध्ये कशी हीट ट्रान्सफर होणार आहे बिकॉज ऑफ द कन्व्हेक्शन. So write down these 4 equations for the 4 mode of heat transfer. So write down Q is equal to HHF into 2 pi R1 into L, THF minus T1. हे लक्षात ठेवा, THF minus T1 हॉट फ्लुइड साठी काय असणार आहे सेंटरला, THF हे कशाचं, हॉट फ्लुइडचं टेम्परेचर आहे आणि इनसाइड लेअरचं टेम्परेचर T1. लेअर A मध्ये टेम्परेचर बाउंड्री काय आहे तर T1 T2 आहे. लेअर B मध्ये टेम्परेचर बाउंड्री काय आहे T2 T3 आहे आणि सराउंडिंगला काय असणार आहे तर T3 आणि TCF असणार आहे. So in that way we have to change the notation. So Q is equal to what, HHF into 2 pi R1 into L, THF minus T1. Then for layer A, Q is equal to heat transfer rate सेमच असणार आहे कारण इनसाइडची हीट जेवढी आहे तेवढीच हीट आपल्याला बाहेर भेटणार आहे. म्हणजे प्रत्येक लेअर मधून जी काही ट्रान्सफर होणार आहे ती सेम असणार आहे. सो देअरफॉर ऍट द लेफ्ट हँड साइड वी हॅव रिटन दी Q. Okay, Q is equal to KA into 2 pi L into bracket T1 minus T2 divided by ln of R2 by R1. R2 by R1. Then Q is equal to KB into 2 pi L into T2 minus T3 divided by ln of R3 by R2. इक्वेशन सेम असणार आहेत फक्त नोटेशन चेंज होणार आहे. लेअर बी मध्ये रेडियस काय असणार आहे, R2 आणि R3 रेडियस आहे म्हणजे इक्वेशन काय येणार आहे, ln of R3 by R2 येणार आहे. आणि टेम्परेचर चेंज काय असणार आहे, T2 आणि T3 असणार आहे. सो देअरफॉर T2 minus T3 आणि थर्मल कंडक्टिव्हिटी KB म्हणून आपण KB घेतलेला आहे. Okay, so Q is equal to KB into 2 pi L into bracket T2 minus T3 divided by ln of R3 by R2. Okay, and for the outside layer, Q is equal to HCF into area. Area काय असणार सरफेस एरिया आउटसाइड सरफेसचा तर 2 पाय RL असते, पण रेडियस काय आउटसाइड सरफेसची R3 आहे. सो देअरफॉर 2 पाय R3 into L into bracket T3 minus TCF. T3 minus TCF. ओके, समजले का बघा सगळ्यांना? हे चारीचे जे काय मोड ऑफ हीट ट्रान्सफर आहे त्याच्यासाठी आपण काय लिहिलेलं आहे, इक्वेशन लिहिलेलं आहे. ओके, याच्यावरून परत रिअरेंज करायच्या टर्म. सो वी हॅव टू राईट डाऊन द इक्वेशन फॉर द टेम्परेचर डिफरन्स. We have to write down the equation for THF minus T1. So from this equation we have to write down the equation for the THF minus T1. त्याच्यासाठी इक्वेशन काय मिळणार आहे, Q divided by HHF into 2 pi R1 into L. That is the equation number 1. Similarly for this, by using this equation we have to find out the value of T1 minus T2. Similarly by using this equation we have to find out the value of T2 minus T3, and similarly by using this equation we have to find out the value of T3 minus TCF. Okay, so rearranging the above expressions we get, write down, rearranging the above expressions we get. So from this four equations we have to write down the equations for the temperature difference. Okay, so all of you write down this temperature difference equation. Write down THF minus T1 is equal to THF minus T1 is equal to Q upon HHF into R1 into 2 pi L. That is the equation number 1. Fast lesser again. Then T1 minus T2 is equal to Q upon K into 2 pi L divided by ln of R2 by R1. That is the equation number 2. Then what is the equation number 3? T2 minus T3 is equal to Q upon KB into 2 pi L divided by ln of R3 by R2. That is the equation number 3. Then T3 minus TCF is equal to Q upon HCF into R3 into 2 pi L, and that is the equation number 4. म्हणजे जे काय वरची चार इक्वेशन आहेत ते आपण फक्त टेम्परेचर डिफरन्सच्या फॉर्म मध्ये लिहिलेले आहेत. वी हॅव टू राईट डाऊन द इक्वेशन इन द फॉर्म ऑफ टेम्परेचर डिफरन्स. ओके, झाले का सगळ्यांचे? चला प्रोसीड. All of you written these four equations so that I will proceed for the next step. समजले का बघा? वरचीच इक्वेशन आपण रिराइट केलेली आहे इन द फॉर्म ऑफ टेम्परेचर डिफरन्स and given the names for that equation, equation 1, equation 2, equation 3 and equation 4. टेम्परेचर डिफरन्स आपल्याला इक्वेशन मिळालेले आहेत THF minus T1, then T1 minus T2, then T2 minus T3 and then T3 minus TCF. Okay, in next step add the equation 1 2 3 4. Adding the equation 1 2 3 4 म्हणजे काय करा, ऍडिशन करा. We have to add the left hand side of the each equation, then we have to add the right hand side of the each equation. So by the adding the left hand side of the each equation we get the T1 cancel होणार आहे, T2 cancel होणार आहे, T3 cancel होणार आहे. What is the remaining term in the left hand side? THF minus TCF. And what about the right hand side? We have to add this all terms, whatever the terms which is at the right hand side, we have to add all the terms. Okay, so adding equation 1 2 3 and 4, adding equation 1 2 3 and 4, adding equation 1 2 3 and 4. add करा ही equation 1 2 3 4. काय मिळेल बघा? So by adding this equation 1 2 3 4, THF minus T1 plus T1 minus T2 plus T2 minus T3 plus T3 minus TCF is equal to, we have to take Q by 2 pi L is common from the right hand side term. So what is the remaining term in the equation? 1 upon HHF into R1 plus 1 upon K into K divided by ln of R2 by R1 plus 1 upon KB into ln of R3 by R2 प्लस 1 अपॉन HCF इंटू R3. जे काही राईट हँड साइडला टर्म आहे त्याच्यामधून आपण Q बाय 2 पाय L कॉमन घेतलेला आहे आणि रिमेनिंग टर्म्स वी हॅव टू रिटर्न इन दी इक्वेशन. सो फ्रॉम द लेफ्ट हँड साइड minus T1 plus T1 will be cancelled, minus T2 plus T2 will be cancelled, minus T3 plus T3 will be cancelled. So what is the remaining term at the left hand side? That is THF minus TCF. THF minus TCF is equal to what? Q upon 2 pi L into bracket 1 upon HHF into R1 plus 1 upon K into K divided by ln of R2 by R1 plus 1 upon KB divided by ln of R3 by R2 plus 1 upon HCF into R3. Our aim is to calculate the value of Q, that is rate of heat transfer through that particular composite cylinder. So we have to take Q as a subject. So Q is equal to what? 2 pi L. We have to take at the another side. So Q is equal to what? 2 pi L into bracket THF minus TCF, and whatever the remaining term we have to take at the denominator. So 1 upon HHF into R1 plus 1 upon K divided by ln of R2 by R1 plus 1 upon KB divided by ln of R3 by R2 plus 1 upon HCF into R3. 1 upon HCF into R3. समजले का बघा सगळ्यांना? ज्यावेळेला कॉम्पोजिट सिलेंडर असणार आहे at that time how to find out the rate of flow through that particular composite cylinder. So for that we have to use this equation. Q is equal to 2 pi L into bracket THF minus TCF bracket complete divided by तेच आपण इक्वेशन परत रीराइट केलेलं आहे. हाऊ टू रीराइट दॅट इक्वेशन? Q is equal to 2 pi L Q is equal to 2 pi L into bracket THF minus TCF. Q is equal to 2 pi L into bracket THF minus TCF 1 upon HHF into R1 plus आपण ln of R2 by R1 डिनॉमिनेटरच्या डिनॉमिनेटरला घेतलेला म्हणजे तू कुठे घेऊ शकतो आपण न्यूमरेटरला घेऊ शकतो. सो ln of R2 by R1 divided by K plus ln of R3 by R2 divided by KB plus 1 upon HCF into R3. 1 upon HCF into R3. So this is the final equation. So by using this equation we have to calculate the rate of heat transfer through that composite cylinder. Composite cylinder जर आपल्याला heat transfer rate find out करायचं असेल, आता इथे किती layers आहेत? If there are 2 layers A and B, then according to that we get the equation. समजले का बघा? If there are 2 layers, then this is the equation. 2 convection resistances are there and 2 conduction resistances are there. If suppose 3 layers are there, then another layer, another resistance which is due to the conduction will be added into that denominator. समजले का? जेवढे काही हीट कंडक्शन मोड ऑफ हीट ट्रान्सफर असणार आहे तेवढे काय असणार आहेत? रेजिस्टन्सेस येणार ॲट दी डिनॉमिनेटर. ओके. सो इफ देर आर n कॉन्सेंट्रिक सिलेंडर्स, आता हे काय झालं? 2 लेयर असताना आपल्याला इक्वेशन मिळालेलं आहे. सो व्हॉट इज द स्टँडर्ड इक्वेशन इफ देर आर n कॉन्सेंट्रिक सिलेंडर्स? इफ देर आर n कॉन्सेंट्रिक सिलेंडर्स काय होईल सांगा इक्वेशन मध्ये चेंज? सो whatever the numerator, that is same numerator will be there, 2 pi L into THF minus TCF, because inside temperature is THF and outside temperature is TCF. But if there are n concentric cylinders in between that 2 layers, then what will happen? What is that equation? So if there are n concentric cylinders, then what is that equation? So write down this equation. Q is equal to 2 pi L into bracket THF minus TCF. THF minus TCF पहिली टर्म सेम असणार आहे कारण हीट ट्रान्सफर जे काही सेंटरला हॉट फ्लुइड असणार आहे त्यामुळे त्याचा रेजिस्टन्स काय असणार आहे? 1 अपॉन HHF into R1 प्लस म्हणजे जे मधले 2 लेयर साठी 2 इक्वेशन मिळाले तर n लेयर्स असतील तर तिथे आपल्याला n इक्वेशन्स मिळणार आहे. सो हाऊ टू राईट दॅट टर्म? 1 upon Kn into ln of Rn plus 1 divided by Rn, and n changes from 1 to n. In that manner we have to write the middle term, म्हणजे जेवढे रेजिस्टन्सेस असतील कंडक्शनचे तेवढे टर्म काय होणार आहेत? तिथे येणार आहेत. सो हाऊ टू राईट दॅट टर्म? 1 upon Kn ln of Rn plus 1 divided by Rn, and that n value changes from 1 to n. म्हणजे जेवढे रेजिस्टन्स असतील, आता इथे n रेजिस्टन्स असतील तर n टर्म येणार आहेत, 2 रेजिस्टन्स असतील तर 2 टर्म येणार आहेत. सो इन दॅट वे वी हॅव टू राईट दी इक्वेशन. म्हणजे 3 लेयर असतील तर काय इक्वेशन येणार? तर 3 टर्म येणार आहेत. ओके. 4 layers असतील तर 4 टर्म येणार आहेत. So in that way we have to write down the equation. So this is the equation for the if there are n concentric cylinders are there. N concentric cylinders are there. आता मला तुम्ही सांगा If inside and outside heat transfer coefficient are not considered, then the above equation can be written as. कसं इक्वेशन लिहू शकतो सांगा? इनसाइड आणि आउटसाइड हीट ट्रान्सफर कोएफिशिएंट जर दिला नसेल आपल्याला, then how to write this equation? If inside and outside heat transfer coefficient दिला नसेल तर म्हणजे काय असणार आहे? This term becomes 0, 1 upon HHF into R1, and this term becomes 0. आउटसाइड आणि इनसाइडचा हीट ट्रान्सफर कोएफिशिएंट दिलेलं नाही, म्हणजे HHF दिलेलं नाही, HCF दिलेलं नाही. So this term becomes 0, this term becomes 0. So how to write that equation? How to write that equation? That is the Q is equal to, ह्या दोन टर्म फक्त कॅन्सल होणार आहेत. If there is a convection heat transfer coefficients are not given, means HHF and HCF is not given. So for that condition, these two terms becomes 0. This two term becomes 0. 1 upon HHF into R1 and 1 upon HCF into Rn plus 1. That terms becomes 0. So what is the remaining? We have to write down that equation. If inside and outside heat transfer coefficient are not considered, if inside and outside heat transfer coefficient are not considered, then the above equation can be written as, Q is equal to what? 2 pi L. आता इथे THF आणि TCF हे टेम्परेचर डिफरन्स जो आहे तो कशाचा होता? हॉट फ्लुइड आणि कोल्ड फ्लुइडचा होता. पण आतमध्ये आपण काय कन्सिडर केलं? हॉट फ्लुइड नाही आणि सराउंडिंगला कोल्ड फ्लुइड नाही. मग टेम्परेचर रेंज काय येणार आहे? सांगा? T1 मायनस आणि लास्टचा लेअर काय असणार आहे? TN प्लस 1. 3 लेअर असतील तर तिथं काय येणार आहेत? 4 टेम्परेचर डिफरन्स. T4 is there. If n layer is there, then Tn plus 1 is there. समजतंय बघा. So according to that, we have to change the equation. Q is equal to 2 pi L into bracket T1 minus Tn plus 1 bracket complete divided by summation of 1 upon Kn ln of Rn plus 1 divided by Rn. N changes from 1 to n. Okay. टेम्परेचर डिफरन्स पण चेंज होणार आहे, कारण हॉट फ्लुइड नाही, कोल्ड फ्लुइड नाही, म्हणजे ही टर्म पण कॅन्सल होणार आणि टेम्परेचर चेंज जो असणार आहे तो पण चेंज होणार आहे. THF मायनस TCF च्या जागेला काय येणार आहे? T1 मायनस Tn प्लस 1. Tn minus Tn plus 1. Okay. So this is the final equation. If the inside and outside heat transfer coefficient is not there, means hot fluid is not there and cold fluid is not there, then what is that equation? So we have to write down the equation in the manner of Q is equal to 2 pi L into bracket T1 minus Tn plus 1 divided by 1 upon Kn into ln of Rn plus 1 divided by Rn, and n value changes from 1 to n. N value changes from 1 to n. Okay. So this is the equation for the composite cylinder. This is the equation for the composite cylinder. In next lecture, we have to solve the heat conduction through the hollow sphere. आता आपण सिलेंडर साठी बघितलं, त्याच्यानंतर composite cylinder साठी बघितलं. In next lecture, we have to derive the derivation for the sphere and then for the composite sphere. Okay. So all of you put your roll numbers in the chat box. Thank you very much.